This is RB Chaurasia. Today, the topic is three-dimensional coordinate geometry. Three-dimensional coordinate geometry is one of the important chapters from the class 12 and higher classes, for the higher classes. It is the very essential that infinite number of points in a space. There are infinite number of points in a space. We want to identify each and every point of space with the help of three mutually perpendicular coordinate axes OX, OY, and OZ. Here is OX, three mutually perpendicular, that is the OX, OY, and OZ. That the three mutually perpendicular axis is in here. The mutually perpendicular lines OX, OY, and OZ are considered as the three axes. The plane formed with the help of X and Y axis is called X and Y axis is called XY plane. XY plane. Similarly, suppose that here देखिए this plane, this is the X axis, Y axis, the XY plane. This is space occupied by this. This is the Y and Z. So this plane is known as the YZ plane. YZ plane. And similarly, this is the Z or X. So this is called the ZX plane. ZX plane. How much? Three planes. XY plane, YZ plane, XY plane, YZ plane, and ZX plane. Consider any point P in the space. Suppose we are considering any point here, P in the space. Consider any point P in the space. Drop the perpendicular from the point to XY plane. Drop the perpendicular, drop करिए यहाँ से perpendicular line to the XY plane. Perpendicular line to the XY plane. Whatever the inherent and extend. Join, and this will take the extension. Will also take the extension. Join here that this is the point. This is the point. Are you sure? P point we have taken perpendicular on. The algebraic length of this perpendicular is considered as Z coordinates. As Z coordinates, algebraic length. Considered as Z coordinates. Z coordinates. Are you sure? Considered as Z coordinates, and from foot of the perpendicular, drop perpendicular to X and Y axis. These algebraic length of perpendiculars are considered as Y and X coordinates respectively. Consider मिला दीजिए इसको, यहाँ से यहाँ कीजिए, ड्राइंग में Suppose this coordinate is x, y, z. Small x, y, z. So what will be these names? This is the x. This is the y. And this will be the z. X, Y, Z. So know that the unit vector along x-axis, unit vector along x-axis, unit vector along x-axis is I denoted by I cap. Unit vector of y-axis along denoted by J cap, that's J cap. And unit vector of z-axis K. It means here modulus of I is equal to modulus of J is equal to modulus of K is equal to 1. So it is a unit vector along the x-axis. Unit vector along y-axis is Z. Unit vector of z-axis is K. Linear components along x-axis. What is here? Linear components along x-axis. Linear components along x-axis is equal to xi cap. X is the distance, so I is the unit vector. Combine कर दिया. Same way, linear components along y-axis is equal to yj cap. Yj cap. Same way, linear components along z-axis is equal to zk cap. Zk cap. So linear combination of OP. What will be the linear combination? Linear combination. Linear combination. A linear combination vector representation of a point P in space, the same thing. Xi cap, yj cap, zk cap. Vector representation OP is equal to xi cap plus yj cap plus zk cap. This is the first thing. Second things we are going to see that the distance formula. Distance formula. What is distance formula? See that distance formula. Distance formula AB, 2 points suppose here. Point is A and another point is B. Its coordinate is x1, y1, z1. 2 points. Its coordinate is x2, y2, z2. What will be the position vector? Suppose origin is here O. The position vector OA and here position vector OB. OB. So AB is equal to what happens? AB is equal to OA, OB minus OA modulo. Position vector we are always taking from the origin, whatever the origin. position vector. So position vector AB. So AB, B is last. So B point, position OB or minus OA. What is OB? OB point लिखे OB x2 y2 z2. What is OB? It means x2 I cap plus y2 j cap plus z2 k cap minus OA. OA x1 y1 z1. Here. What is coordinates of A? x1 y1 z1. What will be the linear combination? x1 I plus y1 j plus z1 k. x1 I plus y1j plus z1k is the linear combination. See that x2 minus x1. This is equal to x2 minus x1 I plus y2 minus y1 j plus z2 minus z1 k. Yeah. So we are taking hand the modulus definition of this means what is the here OP is equal to x1I y1j z1k. What will be the modulus of OP? Modulus of OP x squared plus y squared plus z squared the under root. On the same basis, what will be the here modulus? It will remove. That means under root x2 minus x1 का whole square plus y2 minus y1 का whole square plus z2 minus z1 का whole square under root. That is the distance formula. Distance formula is here. It is the distance formula x2 AB modulus AB is equal to x2 minus x1 का whole square plus y2 minus y1 का whole square plus z2 minus z1 का whole square. Distance of a point P from coordinate axis. Note down. Distance of a point P from coordinate axis. Let PA, PB and PC are distance of a point P which coordinate is x, y, z from a coordinate axis OX, OY, OZ respectively, then PA is equal to under root y squared plus z squared. PA is equal to under root y squared plus z squared. PB is equal to under root x squared plus z squared, and PC is equal to under root y squared x squared plus y squared. There are the three things. That means PA is equal to under root y squared plus z squared, PB is equal to under root x squared plus z squared, and PC is equal to x squared plus y squared. And now section formula is in the class 10th also. The students have read section formula. Section formula, there are the three types of the section: internal section, bisection, and external section. Internal sections, it means we can see that if a line is here, AB line is here, coordinate is x1, y1, z1, coordinate is x2, y2, z2, or internal section, it means from here. Bisection means that is the line A and B coordinate is the same. Bisection, it means from middle. That is the section from here. External means this is the line AB. Then three types of the section. So it means it is essential that you know very well that what will be the section formula. Coordinates of P will be the mx2 plus nx1 upon m plus n. My2 plus ny1 upon m plus n. mz2 plus nz1 upon m plus n. Or midpoint will be the suppose it is the ratio is m and n. Bisection means 1 1. Here is the AB. AB is m, AC is m, and BC is n. Bisection. To see that what will be the section? Internal section. If coordinates is here, suppose we want to find the coordinate is x, y, z. So what will be the section? mx2 plus nx1 mx2 plus nx1 upon m plus 1 my2 plus ny1 upon m plus 1 and mz2 plus mz1 upon m plus n. Then bisection it means coordinate is x1 z1 and x2 y2 z2. What will be the x1 plus x2 by 2, y1 plus y2 by 2, z1 plus z2 by 2. And external sections, what will be the nx2 minus nx1 upon m minus 1, my2 plus minus ny1 upon m minus n, nz2 minus nz1 upon m minus n. This is the section formula. Section formula: bisection, internal section, bisection, and external section. That is the three formula. As you know that the centroid of the triangle, if any triangle is in here, if any triangle, we will make here the any triangle, so what will be the centroid and what will be the in center of a triangle, and centroid of a triangle and in center of the triangle. What is the things you can see here very properly way of the name. Centroid of a triangle, it means a triangle is here, we have made here a triangle. A, B, C. Coordinate is. Its coordinate is x1, y1, z1. Its coordinate is x2, y2, z2. Its coordinate is x3, y3, z3. Centroid. It means this is the centroid. We want to find the C. What is the centroid? Centroid C is equal to x1. Centroid coordinate of C. What will be the its coordinate? C centroid C is equal to x1 plus x2 plus x3 by 3, y1 plus y2 plus y3 by 3, z1 plus z2 plus z3 by 3. This is the centroid C of this triangle. Centroid C of this triangle. In center of triangle ABC, what will be the in center? In center of the triangle will be the, take the length first. Its opposite side for in center. In center is equal to, take the opposite of this A Angle is A, side is BC. This is denoted by small a. B angle is here, so this side is denoted by small b. AC is equal to. This angle is C, this side is denoted by small c. In center, coordinates of I, ये center को ले लेगा, suppose I is here. What will be the coordinates of I? In center I is equal to ax1 plus by1 plus cz1 upon a plus b plus c. ax1 plus bx2 plus cx3 upon a plus b plus c. फिर होगा ay1 plus by2 plus cy3 upon a plus b plus c. फिर तीसरा पॉइंट az1 plus bz2 plus cz3 upon a plus b plus c. That is the in center. In center. If we suppose it BC is equal to A side, AC is equal to denoted by B, and AB is denoted by C, then in center I is equal to AX1 plus BX2 plus CX3 upon B plus C. AY1 plus BY2 plus CY3 upon A plus B plus C. AZ1 plus BZ2 plus CZ3 upon A plus B plus C. Are you sure? That means the you can note that the centroid of a tetrahedron, point 4 point tetrahedron, you know that there are the 4 point A, B, C, D. A, B, C, D, small a भी 4 साइड डिनोट होंगे. Coordinate of A, x1, y1, z1. Coordinates of point B is x2, y2, z2. Coordinates of point C is x3, y3, z3. And coordinates of point D is x4, y4, z4. These 4 are the vertices of a tetrahedron. Then coordinates of the centroid G. Coordinates of the centroid G, centroid को C से डिनोट करते हैं. Centroid C is sigma xi upon 4, sigma yi upon 4, and sigma zi upon 4. Centroid of the tetrahedron. What will be the centroid of the tetrahedron? Coordinates you have note down. Sigma xi upon 4. It means, what means? The x1 plus y1 x1 plus x2 plus x3 plus x4 by 4. Like the same way, sigma yi upon 4, it means y1 plus y2 plus y3 plus y4 by 4. And same way, the sigma zi upon 4 is equal to. The same will take place. That is the centroid of a tetrahedron. Now, this is the fundamental things, whatever you have learned. That means what is the linear components, sum of the xi, OP vector is equal to xi plus yj plus zk. Modulus of OP is under root x squared plus y squared plus z squared. The distance formula you become familiar. In modulus AB is equal to x2 minus x1 का whole square plus y2 minus y1 का whole square plus z2 minus z1 का whole square. Third things you become familiar about the centroid of a triangle. If section formula you become familiar, that the internal sections, if a line AAB, internal section formula and was the mx2 plus nx1 upon m plus n, my2 plus ny1 upon m plus n mz2 plus nz1 upon m plus n. The internal sections. External sections minus will take place. mx2 minus nx1 upon m minus n. my2 minus ny1 upon m minus n. nz2 minus n mz2 minus nz1 upon m minus n. This is the external. So bisection was the x1 plus x2 by 2, y1 plus y2 by 2, z1 plus z2 by 2. Afterwards, you have become familiar about the centroid of the triangle. If a triangle ABC having the coordinate x1, y1, z1, B coordinate is x2, y2, z2, and C coordinate is x3, y3, z3, then centroid of the triangle will be the x1 plus x2 plus x3 by 3, y1 plus y2 plus y3 by 3, z1 plus z2 plus z3 by 3. In center, same way. In center, for taking the in center, the opposite side, corresponding sides of the A. Angle A is BC, it is denoted by small a. The length of the BC. Same way, length of AC is the B, small b. Length of AB is small c. And in center, I is equal to AX1 plus BY1 plus CZ1 upon AX1 plus BX2 plus CX3 by upon A plus B plus C. Like the same way, AY1 plus BY2 plus CZ3 upon A plus B plus C. AZ1 plus BZ2 plus CZ3 upon A plus B plus C. Afterwards, you become familiar about the tetrahedron. Tetrahedron, centroid of the tetrahedron. Tetrahedron, it means the four vertices in the tetrahedron A, B, C, D. The coordinates of A is x1, y1, z1. Coordinates of B is x2, y2, z2. And coordinates of C is x3, y3, z3. And coordinates of D is x4, y4, z4. Then centroid C in a tetrahedron is sigma xi by 4, sigma yi by 4, sigma zi by 4. It means xi means x1 plus x2 plus x3 plus x4 by 4. Y1 like the same way. Up to this stage you become familiar. Now we are going to see that the direction cosine and direction ratio. What is the directional angle, direction cosine and direction ratio? It is the one of the important factors is in the three dimension. If the students know very well that the directional angle, directional cosine and direction ratio, then it means the main soul of the three dimension. We will come to the here very soon. The things. Directional, directional angle, direction cosine, and direction ratio. The students have read already in the class 10 and 11 the trigonometry. The cosine. What is the cosine? Cosine means cos. Cosine means cos. Cos का see that here. That is the we are going to see that the direction direction cosine and direction ratio. Direction cosine and direction ratio. We are going to see. X, Y, and Z axis. X, Y, and Z axis. We are taking the any point P here. Join OP. OP को join OP. The sum angle that OP makes with the x-axis. OP makes with the x-axis. X-axis के साथ में जो एंगल बनाएगा that is denoted by alpha. OP makes angle with y-axis. Y-axis के साथ में जो एंगल है that is the beta denoted by beta. Whatever the OP makes the angle with the z-axis that is denoted by gamma. Alpha, beta, gamma are called known as the directional angle. What is the directional angle of OP along x-axis? Alpha. Along y-axis, beta. What is along z-axis? That is the gamma. When we are placing these things, this angle with cos, that is called the directional cosine. Cosine means cos. Cos alpha, directional cosine with x-axis. X-axis के साथ में directional cosine क्या है? Directional cosine cos alpha. Y-axis के साथ में cos beta, क्योंकि y-axis के साथ में बीटा एंगल बना रहा है और z-axis के साथ में गामा एंगल बना रहा है, तो z के गामा के साथ cos लगा दीजिए. That will be the cos gamma. Directional cosine हो गया. Cos alpha, cos beta, cos gamma are the directional cosine along x-axis, y-axis, and z-axis. Suppose देखिए फिर से एक बात देखिए. Let alpha, beta, and gamma, alpha, beta, and gamma be the angle with a directed line makes with the positive direction of the axis of x, y, and z respectively. Then cos alpha, cos beta, cos gamma are called the direction cosine of the line. The direction cosine are usually denoted by L, M, and N. Direction cosine denoted by L. It means L is equal to cos alpha, M is equal to cos beta, and N is equal to cos gamma. And some relation is also here. एक रिलेशन है L square plus M square plus N square is equal to 1. It means cos square alpha plus cos square beta plus cos square gamma is equal to 1. That is the direction cosines. If direction ratio, then what will be the direction ratio? Let small a, small b, small c, a, b, c be proportional to the direction cosine L, M, and N then A, B, C are called the direction ratio. If A, B, C are the direction ratio of any line L, then Aij plus Bj cap plus Ck cap, Ai cap plus Bj cap plus Ck cap will be a vector parallel to the line L. If L, M, and N are the direction cosine of a line L, then Li cap plus Mj cap plus Nk cap is a unit vector parallel to the line L. If LMN be the direction cosine and ABC are the direction ratio of a vector, then L is equal to LMN with the direction cosine of a line of a vector AB suppose, and ABC ये वेक्टर है, ये लाइन है OP या ये लाइन है AB लाइन, इसका डायरेक्शन कोसाइन क्या है L M N, डायरेक्शन रेशियो क्या है A B C. Then what happens, L is equal to क्या होगा, M is equal to क्या होगा, N is equal to क्या होगा. L is equal to plus minus A upon under root A square plus B square plus C square. M is equal to plus minus B upon under root A square plus B square plus C square. And N is equal to plus minus C upon under root A square plus B square plus C square. Are you sure? That means this is the if OP is equal to R, suppose when O is the origin and the direction cosine of OP are L, M, N, then the coordinates of OP of point P will be the LR, MR, and NR. LR, MR, and NR. The OP है तो यहाँ पे कोऑर्डिनेट हो जाएंगे इन द सेंस ऑफ द डायरेक्शन कोसाइन LR, MR, and NR. It means if direction cosine of a line AB are LMN and modulus AB is equal to R, then the coordinates of A is x1, y1, z1. So the coordinates of B is given x1 plus RL1, y1 plus RM, z1 plus RM. फिर से ध्यान से देखिए, इसको ध्यान से देखा जाए, यहाँ पे इसके होंगे, ध्यान से देखिए, if the coordinates of P and Q are x1, y1, z1 and x2, y2, z2, then the direction ratio of line PQR A is equal to x2 minus x1, B is equal to y2 minus y1, C is equal to Z2 minus Z1. And the direction cosine of a line PQR, L is equal to x2 minus x1 upon modulus PQ, M is equal to y2 minus y1 upon modulus PQ, and N is equal to Z2 minus Z1 upon modulus PQ. Direction cosine, direction cosine direction cosine of x-axis, what happens? Y-axis, what happens? And z-axis, y happens. Direction, if